Hi, Mr. Wright here, and welcome to this walkthrough of January 23 Paper 1F. If you are preparing for your Edexcel IGCSE Maths Foundation, then this will be perfect for you. If you have a look in the description, you can click on a link and download the paper, and then you can work on the paper before you watch the film, or you can watch the film as you watch the paper. You can watch the film as you work on the paper, and then you can work alongside me, entirely up to you. Also in the description, you'll find links to various parts of the film, so if you don't want to watch the whole film, you don't have to. And at the end of this film, I've given you details of what the grade boundaries are, so that you can see what grade you would have got if you were sitting this paper for real. If you find this film useful, hit like, leave me a comment, tell me so, and if you've got any questions, of course, leave them in the comments, and of course I'll respond and give you a hand. So, let's get on with the maths. Question 1. The table gives information about 6 plays written by William Shakespeare. Now, let's take a minute, just make sure that we're clear about what the table's telling us. I see we've got the names of 6 plays here, and this column tells us the number of words in each play, and this column tells us the year in which each play was written. Right, let's have a look. A, which of these 6 plays has the greatest number of words? So we're looking in the middle column here. It looks to me as if it is Hamlet that has the greatest number of words because it has 30,000 words more than any other. 2 of these 6 plays were written in the same year. Write down the names of these plays. Right. Which plays are written in the same year? I'm looking for the same number. Down here, why can't I see it? Ah, here it is. 1599, 1599. So, Julius Caesar, spelt that wrong, and Henry V. Okay. The play Othello has 9,329 more words in it than the play Macbeth. Okay. Work out the number of words in the play Othello. Well, Othello isn't on my list, but I can see that Macbeth has got 17,121 words, and Othello has 9,329 more. So on my calculator, I'm going to do 17,121 plus 9,329 to give me the answer 26,450. And part D, write this number in words. Well, that is 21,000, no hundred, so 21,055. And that is question 1 finished. Question 2. Luca has 5 kilograms of chopped tomatoes. I'm already thinking I know what that is in grams. He also has some empty tins. Okay. When full, each tin holds 350 grams of chopped tomatoes. Luca fills as many tins as possible with the chopped tomatoes. Work out the weight of the chopped tomatoes remaining after Luca has filled as many tins as possible. Give the units of your answer. I'm going to have to remember that, aren't I? Give the units of your answer. Right. Well, he's got 5 kilograms of chopped tomatoes, so that is 5,000 grams of chopped tomatoes. Each tin holds 350 grams, so I'm going to work out how many 350s there are in 5,000 to work out how many tins he can fill. Now, he can fill 14 and a bit tins. 14 and a bit. So, I need to work out how many grams there are in that bit remaining, don't I? Well, in the 14 tins, he'll have 14 times 350, won't he? 14 times 350. He'll have 4,900 grams of tomatoes. So he'll have 100 grams left. So the weight of the tomatoes remaining after he's filled as many tins as possible is 100 grams. And have I given the units in my answer? Yes, I have. And that is number 2 done. Number 3, a sequence of patterns is made from squares. Just pause, have a look at the patterns. It looks to me like pattern 1 and then pattern 2's got those added on. And then here's pattern 2 and pattern 3 adds on one more to each of those spurs coming out, doesn't it? In the space below, draw pattern 4. Well, let's start by drawing pattern 3. Pattern 3 looks like this. Now that's pattern 3. So pattern 4 will be pattern 3 with an extra one here, an extra one here, and an extra one there. Complete the table. Let's have a look. Pattern number. Look, that's this. Pattern number 1, pattern number 2, pattern number 3, pattern number 4. So pattern number 1, number of squares. Well, pattern number 1's got 1 square, hasn't it? Pattern number 2 has got 4, just like it says here. Pattern number 3, 1, 2, has got 7. Now, pattern number 4, I could count those from my diagram there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, how am I going to work out how many for pattern number 5? Well, I can spot that it's going up by 3 each time. So pattern number 5 will have 13. Work out the number of squares in pattern number 8. Well, if 5's got 13, then I'm thinking 6, 7, 8, add 3 each time. So I'm thinking pattern 8's got 22. Angus says there are 42 squares in pattern number 15. Angus is incorrect. Explain why. Well, we could work out how many squares there are in pattern 15, couldn't we? Now, if you want to do that, you can just carry on here. Do 9, 10, 11, 12, 13, 14, all the way up to 15. Or you could work out the formula, because it adds 3 each time, doesn't it? So the formula is going to be 3n, and then the first term isn't 3, it's 1. Sorry, I should be pointing that one. The first term isn't 3, it's 1, so it's going to be 3n minus 2 is the formula. So in pattern 15, it'd be 3 times 15 minus 2, 45 minus 2, well, that's 43. So I could then write pattern 15 has 43 squares in it. And with any luck, if you did it this way, just by carrying on the pattern, you would have got 43 as well. And that is question 3 done. Question 4. Write 0.8 as a percentage. Well, that's 8 tenths, so it's 80 out of 100. Write down the value of the number 3. Well, we've got units, then tenths, then hundredths. So the 3 is thousandths, isn't it? So I would write 3 thousandths. Write these decimals in order of size. Start with the smallest. Well, there are lots of ways of thinking about this. Sometimes people find it easier to think about each one as being money. So I'm going to do this one by thinking about each one as doing money, but it doesn't mean you have to do the same method. Now, this one is only 4.2 pence. Look at this one. This one's 4 pence. So that one's the lowest, isn't it? So 0.04 is the lowest. Give it a tick because I've included it. And now 0.042 because that's 4 pence and a bit more. Now, shall I choose 20 pence, 24 pence, or 20 pence and a bit? I'm going to choose 20 pence, then 20 pence and a bit, and then 24 pence. Write this number to correct to 2 decimal places. Right, well, here's the number, 2 decimal places. That'll be the cutoff point. Will the 8 go up? Yes, it will, because it's followed by a 6. So 2579. Find the square root of that. Well, I can do that on my calculator using the square root button. And the answer is 36. And that is question 4 done. Question 5. Adam has 8 packets of noodles. 8 packets. Here are the flavour of the noodles in each packet. And I can see there are 8 here, aren't there? So those are the flavours of his 8 packets of noodles. Adam takes at random a packet of noodles. On the probability scale, mark with a cross the probability that Adam takes a packet of hot and spicy noodles. Right, hot and spicy. Those ones, those ones, those ones, and those ones. Look at that. Isn't it 4 out of 8? So the probability of him taking hot and spicy is a half, or 0.5. Circle the word that best describes the likelihood that he takes a packet of vegetarian noodles. Is it possible at all? Yes, it is. Look, that's 1. Is there only 1 out of 8? So it's possible, but it's unlikely, I would say. There we go. Belinda asks 20 people to name the type of rice they like best. Here are the results. Okay. Complete the frequency table. Right, this is just a test. Can you tick off and tally? Tick off and tally. So do it like this. Do it slowly and carefully. Tick off, tally. Tick off, tally. Tick off, tally. Tick off, tally. You could go along the rows. I'm going down the columns because then I can pause more often. Right, tick off, tally. Tick off, tally. Tick off, tally. Tick off, tally. Now I'm going to need to be careful, aren't I? Because when I get to 5, I need to remember that I tally with the gate. Basmati, tally. Wild, tally. Arbarario, whatever it's called, tally. Jasmine, tally. Oh, I've got 4 jasmines now, so look out. Look at that, jasmine. That's my 5th one. Jasmine, basmati. 4 basmati now. Wild. Remember, when you're doing this, you've got so much time, okay? So don't rush it and get it right. Use a pencil, and then if you want to, you can always rub stuff out. Jasmine, basmati, and finally, the one I can't pronounce. Right, so there are the tallies. Now, let's work out how many times each one appears. 4, 6, 7, 3. Now, I could just quickly add those up and check it comes to 20, because I hope it does, because that's how many people there were voting in the survey. And that is question 5 finished. Let's have a look at question 6. Sandeep sells 600 tickets for an event. He receives a total of $7,200. Okay, a quarter of the tickets are child tickets, and the rest are adult tickets. The cost of an adult ticket is $13.60. Work out the cost of a child ticket. Well, let's start out by working out he's got 600 tickets, right? And it says that a quarter are child tickets. So how many child tickets is that? That's going to be 600 divided by 4, a quarter of 600. So he's got 150 child tickets. Okay. Right. Now it says the rest of them are adult tickets. So that means that the adult tickets must be, well, it's 150 child, so there must be 450 adult tickets. Okay, so I know how many children tickets and how many adult tickets now. Oh, wait a minute. The cost of an adult ticket is $13.60. So I can work out how much money he got from selling the adult tickets. 450 adult tickets sold for $13.60 each. 450 times 13.60. Right, that's $6,120. Now, What shall I work out next then? I know that's how much he got from the adult tickets. And I know he made 7,200 in all. So from the child tickets, he must have got the rest of his money. So I'm going to do 7,200, all the money he took, minus the amount he sold the adult tickets for. And then I'll know how much in total he got from selling the children's tickets. He got that much from selling the children's tickets. And I know there are 150 of them, right? So now I can work out the cost of each child ticket. 1080 divided by 150 tickets means that each ticket was sold for, now I get 7.2 on my calculator. So I'm going to write $7.20 for my answer. And that is question 6 finished. Question 7. Right, simplify. So I've got 5p times 9k, 45kp, or 45pk if you prefer. Simplify, right, I've got 3 e's and another plus 8 e's, 11 e's. I've got plus 2 f's and minus 7 f's. So altogether, that's minus 5f. Solve this one. Now, it depends how you like to do these. I'm going to float and ping this time. So I'm going to float and ping this plus 7. So it turns it into a minus 7. So now I've got 2d equals 16 minus 7 is 9. And now I'm going to escalate this 2 down. So I get d is 9 over 2. So I can work that out with my calculator, 4.5. Okay, that is question 7 finished. Question 8. Now I have a feeling I won't be able to do this on the screen. Let's have a look. Here is a scale drawing showing the positions of Paris and Bordeaux. Okay. Alan drives from Paris to Bordeaux. The distance that he drives is 590 kilometers. The distance is actually greater than the straight line. Well, that's not surprising because the roads won't be along that straight line. How much greater is 590 compared to the distance on the straight line? Well, what you'll have to do is you'll have to measure that straight line. Now, I don't know how many centimeters it is, okay? But for example, if it were 7 centimeters, just say, if it was 7 centimeters, then the straight line would be 7 times 80 kilometers, 560 kilometers. And so then you could do 590 minus 560 to work out how much greater the driving distance is compared to the straight line on the map. But I do not know what that length is. So work it out with your ruler and then measure it with your ruler and then times that amount by 80. And then subtract it from 590. And that is question 8 finished. Question 9. We've got 2 fair spinners. I see spinner A has got a 1, 2, and 3 on it, look. And spinner B has got 1, 2, 3, 4. Spinner A can land on 1, 2, and 3. Yes, spinner B can land on 1, 2, 3, or 4. Right, we're going to multiply the number on which spinner A lands by the number on which spinner B lands. Complete the table. Just take a minute, make sure you understand what's going on with this table here before we start filling it in. So remember, we're multiplying. So that's why this is a 1, I guess, because it's 1 times 1. That's why this is a 4, because it's 2 times 2. Now, once you're sure you know what you're doing, then you can fill in the rest of the table. So it's going to be 2 times 3, and then 2 times 4, and then 3 times 2, 3 times 3, 3 times 4. Spin spinner A. Right, we're going to spin spinner A once and spinner B once. Find the probability that his score, these are the scores. Find out the probability that his score is an odd number. Well, how many of those scores are odd? That's odd. That's odd. None of those are odd in the middle column. That's odd. That's odd. Look at that. 4 of them are odd, aren't they? Out of how many altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 out of 12, which you can cancel to 1/3. And that's question 9 done. Question 10. Orange squash is made from orange juice and water. Okay. Sean has 2 different cartons of orange squash, carton P and carton Q. Look, carton P and carton Q. The table gives information about the 2 cartons. Let's have a look at the table. Let's not rush on to the question. In carton P, you've got that much volume, and 30% of the total volume is orange juice. So therefore, presumably 70% is water, right? The rest is water. So that's carton P. Now, once you understand what's going on with carton P, have a look at carton Q. Total volume of the orange squash is 250. Oh, that's the same, isn't it, as carton P? 160 millilitres of the total volume is water, and the remainder is orange juice. So the remainder must be 90 millilitres, mustn't it? Okay, because there's 250 millilitres in all, and 160 millilitres is orange juice. So 250 minus 160 is 90. Right, I think I've understood everything there. Let's look at the question. Work out the difference in the volume of orange juice in carton P and the volume of orange juice in carton Q. So let's look at carton P. What is the volume of orange juice? Well, it's 30% of the total, isn't it? So it's 30% of 250. So on my calculator, I'm going to do 0.3 or 0.30 times 250. Tells me that 75 millilitres is orange juice. Now let's look at carton Q. It says 160 millilitres is water, and I've already worked out that 90 millilitres is orange juice, haven't I? 90 millilitres is orange juice. So I know that 90 millilitres is orange juice in carton Q. Right, let's go back to the question. Work out the difference in those 2 volumes. So I'm going to do 90 minus 75, so my difference is 15 millilitres. And that is question 10 done. Question 11. On the grid below, draw this graph. Right, here it is. It's y equals 1 minus 2x. Well, I know the gradient is the coefficient on the x, isn't it? So that's my gradient. And I know the y-intercept is that number there. So this graph crosses at 1. And it has a gradient of minus 2. So I'm going to go along 1, down 2, along 1, down 2, along 1, down 2. So here is my graph. Join all those up carefully. And there you have the graph of y equals 1 minus 2x. Number 12. Now we've got to subtract fractions. Now, when you have a show that, I would personally ignore the answer. Work out the answer to this and then check that you get what they say. So ignore that right-hand side. Now, if this was me, I think I would probably decide to put them both over. Now, I know lots of people use the lowest common multiple, and there's nothing wrong with that. And if you do, you put them over 24s. I'm going to put them over whatever 8 times 12 is. I'm going to put them as 96ths. And then I'm going to say, well, I times that by 12, so I'll times this by 12. So 7 times 12 is 84. Minus, now here I've times by 8, so I times by 8. So 5 8s are 40. So I get 84 over 96 minus 40 over 96, which gives me 44 over 96. And now I'm going to put that in my calculator, and it'll cancel it down for me to 11/24, which is what I was supposed to get. Okay, now there's nothing wrong with doing it as 24th straight away. In fact, that's probably better mathematically, but whenever I do these, I always just do them in that method. that I've used in question 12a. Question 12b, find the highest common factor of 130 and 208. Now, you probably know that you have to write these as products of primes. And with any luck, you know that you can use your calculator to simply tell you what each of these numbers are in terms of their prime factors. And in this question, it doesn't say that you have to show how you found your product of primes. So there's no reason at all why you shouldn't just use your calculator to work out each of these numbers as a product of prime factors. You can use a factor tree, of course you can, if you want to. Right, now I'm going to draw my Venn diagram. So I'm going to have 130 on the left and 208 on the right. Now what's in both of them? They both got a 13 and they both got a 2. Now, because in this question I'm asked to find the highest common factor, I don't need to fill in the rest. That's my highest common factor. So the highest common factor is 2 times 13, 26. And that is question 12 done. Question 13. Right, I'm told that P is equal to T minus A times C. And I need to put in these values for T, A, and C. So P will be T, which is 18, minus A, which is minus 3, times 5. Now, if you want to, you can put that straight into your calculator. Or you can write that as 18 minus a minus is a plus 15. So I'm going to get the answer 33. But you would get that answer if you typed this straight into your calculator. Okay, part B, make x the subject of the formula. So I have to rearrange this so I've got x equals everything else. Now the first thing I'm going to do is I'm going to flip it around. So instead of d equals 3x plus 10, I'm going to write 3x plus 10 equals d. Now because earlier in this film I used the, I can't remember what it's called now, float and ping, I'm going to do float and ping this time too. So I'm going to float and ping that plus 10, so it's going to become a minus 10. So I'm going to have 3x equals d minus 10. And now I'm going to take that 3 and escalate it down. So I'm going to end up with x equals d minus 10 over 3. And there is that formula rearranged, so x is the subject. And that's question 13 finished. Where is it? There it is. Right. Question 14. On the grid, rotate triangle A 90 degrees anti-clockwise about the origin. Now, I won't be able to show you this with tracing paper, but I will be able to give you the answer so you can check your own. Now, we're going to go anti-clockwise, so A is going to rotate anti-clockwise, and it's going to go 90 degrees. Okay, now if you do that correctly, then you should end up with this point coming to here. This point will be here, and this point will be there. So that should be your new triangle, and it doesn't tell us to label it. So on the grid, rotate triangle A 90 degrees anti-clockwise about the origin. Done. That's number 14 done. Unless there's a 14b. Here it is. Look at this. Describe fully the single transformation that maps B onto C. So we've got to take B and map it onto C. Now that's going to be an enlargement. So I'm going to write enlargement, or enlarge B. Now I'm going to need a scale factor by a scale factor of, and then I'm going to need a center of enlargement as well. Now the scale factor, here's a pair of corresponding sides, and I see that the side lengths of B have trebled. So the scale factor is 3. Now, what about the centre of enlargement? Well, to find the centre of enlargement, I'm going to use a pencil and a ruler, and I'm going to join up the corresponding vertices, the corresponding corners of each of these shapes. So I'll join up those, and then I'll also choose this one here and join up these ones. Okay, and there you are. Looks to me as if the centre of enlargement is the origin. So I shall say with, you'd have to write it in long form, centre of enlargement of 0, 0. Okay, enlarge by a scale factor with the centre of enlargement. Okay, that's the end of question 14. Let's move on to question 15. Now, here is a floor plan of a stage. The plan is formed from a triangle, yes, I can see that, and a rectangle. Good. The stage manager is going to paint the floor. 1 tin of paint covers an area of that. Oh, I think we're going to have to work out the area, aren't we? And 1 tin of paint costs that much. Paint can only be bought in full tins, okay. He has that much money. Does he have enough money to buy enough tins of paint to paint all the floor? Well, we better work out the area of the floor, hadn't we? So let's work out the area of the floor. Area of floor. Now, what have I got? I've got a rectangle. So that's going to be 3 times 4.8. And then I've got this triangle, haven't I? Now, the area of a triangle is base times height divided by 2. Do I know the base of the triangle? I do, because it's 4.8, isn't it? So base times the height. Do I know the height? Yes, I do. 2.5. And then that is going to be divided by 2. Now, I've just looked at what I've written, and I've got the area of the rectangle there, but I've written times. I don't know why I did that. It's the area of the rectangle plus the area of the triangle. That's going to be the whole area of the floor, so let's work that out. Use my calculator. 3 times 4.8 plus 4.8 times 2.5 divided by 2. Right, I have a whole area of 20.4 square meters. So how many tins of paint will I need? Well, each tin of paint covers 1.8, doesn't it? So I'm going to do the amount of area I've got to paint divided by 1.8. Divided by 1.8. Okay, I'm going to need 11.33 so on tins. So how many tins will I have to buy? I'll have to buy 12 tins, won't I? And how much will that cost? Well, 1 tin costs 16.40. So 12 tins is 12 times 16.40. 16.4 times 12 is $196.80. The store manager has 190. Does he have enough money? Now you have to answer with a yes or a no, because the question is, does the store manager have enough money to buy enough tins of paint to paint all the floor? So that means it needs a yes or a no. So no. And then you could say, he needs 12 tins, which would cost $196.80. There you go. That is question 15 finished. Let's look at question 16. Question 16, 80 students, it might be useful, 80 students entered a dancing competition. The table gives information about the length of time in minutes for which each student spent dancing. Okay, have a quick look. Let's see that we understand what's going on here. What about these guys here? How many students is that? 15 students, and how long did they dance for? Between 36 and 48 minutes. Okay, I kind of understand what the table's all about now. Work out an estimate for the mean length of time. So I'm going to mid-mad this. I'm going to find the midpoints of the classes here, and then I'm going to multiply, add, and divide. And when I divide, I'm going to divide by the total of the frequencies, which I already know is 80, because there are 80 students. So halfway between 0 and 12, 6. Now, if you're not sure what's halfway between, say, 12 and 24, you can do 12 plus 24 equals, and then divide by 2. 18. Halfway between 24 and 36, add them up and divide by 2, and you'll get 30. Add them up and divide by 2, and you'll get 42. Add them up and divide by 2, and you'll get 54. So now I'm going to do 11 times 6, 25 times 18, and so on. Right, 11 times 6, 66. 25 times 18, 450. 23 times 30, 690. 15 times 42, 630. And 6 times 54, 324. Right, I've found the midpoints. I've multiplied. Now I'm going to add. I'm going to add all of these black numbers together. 66 plus 450 plus 690 plus 630 plus 324 gives me a total of 3,000. No, I think that must be wrong. I'm going to do it again. That answer on my calculator doesn't look right at all. 66 plus 450 plus 690 plus 630 plus 324 gives me a total of 2160. Midpoint, multiply, add, and now I'm going to divide 2160 divided by the number of students divided by the 80. Divided by 80 equals. And I get a mean time of 27 minutes. Now, before we move on, just have a look and see if you think that's realistic. Okay, here's the times that people spent, and I think that 27 is a realistic mean there, because some people spent quite a longer than 27, and some people spent less. Okay, that's number 16 done. Right, number 17. Here we are, right. I need to solve this equation. I'm going to start by just copying down the equation. 3 lots of 2 minus 4x equals 5 minus 8x. Let's multiply out that bracket. 6 minus 3 fours are 12x equals 5 minus 8x. Now, when I was doing this paper earlier on, I used float and ping, so I'll use float and ping again. I'm going to see which side has the fewest x's and float and ping them over to the other side. Now, this is the side that has fewest x's because minus 12 is less than minus 8. So I'm going to float and ping those over there. So that's going to become plus 12x, isn't it? So I've got 6 equals 5. Now I had minus 8x. I'm going to plus 12x. So that means that I now have plus 4x. And now I'm going to float and ping this 5 over there. So it becomes a minus 5. So it's going to be 6 minus 5, 1 equals 4x, or 4x equals 1. And now I'm going to escalate down my 4. So I'm going to end up with x equals 1 divided by 4, or a quarter. And that's question 17 done. Right, question 18. Use a ruler and compass is only to construct the perpendicular bisector of the line AB. You must show all your construction lines. Right, I'm not going to be able to do this for real, but I'll show you what you should do. Open your compass. Open your compass, maybe, it's got to be at least half of the length. So maybe open it about there, right? Open your compass. Now, do not change your compass length. Sharp bit in A, pointy bit in A, arc, arc. Do not change your compass. Pointy bit in B, arc, arc. And then, if you join these up with a ruler, you will have a line. Mine's not very good. You'll have a line that actually crosses at right angles there and is halfway between. Number 18. That was number 18. Let's have a look at number 19. The diagram shows a pentagon. Work out the value of x. Well, that's 90. Now I've got every angle in the pentagon, almost, but I just don't know one of them. So I'm going to write an expression of all the angles in the pentagon equals what the total number of degrees in a pentagon should be. Now the total number of degrees in a five-sided shape is 5 minus 2, 3, times 180, 540. So all of these angles, this one plus this one plus this one plus this one plus that one, should equal 540. So I can write an equation now. I'm going to write 90 plus 135 plus 67 plus 119 plus x equals 540. That's the equation I'm going to solve. So if I add up those numbers on the left, 90 plus 135 plus 67 plus 119, I get 411. So 411 plus x equals 540. Float and ping that 411 becomes minus 411. So x is 540 minus 411, 129. And that's question 19 done. Right, question 20. In a box, there are only green sweets, orange sweets, and yellow sweets. There are 280 sweets in the box. Okay, so the number of green to the number of orange is 2 to 3. And also, the number of orange to the number of yellow is 1 to 5. Work out how many green sweets there are in the box. Oh, now, you see how green to orange, let's say green to orange is 2 to 3. And you see how orange to yellow is 1 to 5. Well, if I change this to a 3, multiply that one by 3, so multiply this one by 3, gives me 15 there, then I can combine my ratios, because I can go green to orange is 2 to 3, and I know that orange to yellow is 3 to 15. So look at that, I've combined the ratios now. So now I can find the total of my ratios. Now the total of these ratios is 20. And the total number of sweets in the real world is 280. So what have I multiplied there by? 280 divided by 20 is 14. So if I multiply each of my ratios by 14, I can work out how many green, how many orange, and how many yellow. And I actually only asked for how many green. So my answer is going to be 2 times 14. There are going to be 28 green sweets in the box. Question 21. Shane bought a car. The amount Shane paid for the car was $32,000. Teresa also bought a car. To pay for this car, she paid a deposit of $18,000 and 14 monthly payments of $1,160. Okay. Teresa paid more for her car than Shane paid for his car. Work out how much more Teresa paid as a percentage of the amount that Shane paid. Well, first of all, let's work out how much Teresa did pay. So Teresa paid a deposit of $18,000, and then she paid $1,160 every month for 14 months. So the total that she paid is the $18,000 plus 14 times 1,160. So her total is $34,240. And it says I need to work out how much more Teresa paid as a percentage of the amount that Shane paid. Well, how much more did Teresa pay? Well, Shane paid 32,000 and Teresa paid 34,240. So if I do the amount Teresa paid minus the amount that Shane paid, now I know that Teresa paid 2,240 more than Shane. But what is that as a percentage of the amount that Shane paid? Well, 2,240 out of what Shane paid times by 100. So 2,240 divided by 32,000 equals, times by 100 equals 7. So 7% is the answer. Kylie bought a van. After 1 year, the value of the van was that much. During this year, the value of the van had decreased by 15%. Work out the value of the van when she bought it. So we're being told the amount after the percentage change, aren't we? After the percentage change, it's 39865. So here's the amount at the start. And we know that if we went forwards, we'd decrease by 15%. So if we were going forwards, we'd multiply by 0.85. So if we're going backwards, we're going to start with the 39865 and divide by 0.85. So 39865 divided by 0.85. 39865 divided by 0.85 gives me $46,900. And you could always check by taking 46,900, decreasing it by 15%, and seeing if you get 39,865. That's question 21. Question 22. Some members of a library were asked to name the type of book they each like to read the best. One of the members is chosen at random. Okay. The table shows information about the probability of the type of book that this member answered. So, 0.24 was the probability that they answered comedy, 0.4 was the probability they answered romance, and we don't know the probability that they answered mystery or the probability that they answered thriller. But I do know that all of these have to add up to 1. So I could work out 0.24 plus 0.40, 0.64, and then I know that that lot has to be the rest. So if I do 1 minus 0.64, then I know that these two boxes here must add up to 0.36. Well, one of the boxes is 3x, and the other box is x, and I know they must add up to 0.36. So 4x is 0.36, divide by 4, x is 0.09. So now I know that this one is 0.09, and the mystery one is 3 times 0.09, 0.27. So I haven't really finished reading the question yet, but I've managed to work out that the probability of the person choosing a mystery is 0.27, and the probability of them choosing a thriller is 0.09. Right. 48 members answered comedy books. Work out how many of the members answered mystery books. Well, the probability of comedy is 0.24, and that was 48 members. And it wants to know how many members would be the same as a probability of 0.27, because that's the probability for mystery. Well, 24% of the members is 48, so 27% of the members are just going to times by 2, aren't you? 27 times by 2, 54. So my answer is 54. Okay. Right. Question 23. The diagram shows a triangle ABC inside a semicircle. A, B, and C are points on the semicircle. AB is the diameter of the semicircle. Okay, so here's the diameter. And then it's given me some angles, and lengths, all of which are marked on the diagram. Work out the perimeter of the semicircle. Right. Give your answer to two significant figures. Well, if I'm going to work out the perimeter of the semicircle, part of the perimeter of the semicircle is this length, isn't it? Here. I'll call that D, because after all it is the diameter, so I'll call it little d. How can I work out that length? Well, you see that right angle triangle? You see you've got 18, then a right angle, and then this is D. And you've got a length there, an angle there of 50. You can use Socaterra now. Okay, we're going to use cos, we're going to use ca, because we're trying to find the hypotenuse, and we know the adjacent. So the hypotenuse is going to be D, the hypotenuse, the diameter there, is going to be the adjacent 18 divided by sine 50. Right, 18 divided by sine 50 equals 23.497. So D is 23.497, and so on. Okay. Now I've worked out that length of the diameter. I wonder if I can work out the perimeter of the semicircle. Well, the perimeter of the semicircle is made up of half the circumference of the circle and then this straight bit. So to do the perimeter of the semicircle, I'm going to do perimeter equals, now half a circumference, well the whole circumference is pi d, so it's pi times 23.497 and so on, and I only want half of it, so I'll divide that by 2, and then I need to add on another 23.497 and so on because of the straight bit here, that blue bit. So that's the whole of my perimeter. Let's see what I get. Times by pi equals, divided by 2 equals, plus 23.497 equals, and then I'm going to put my answer to two significant figures. So I get 60.4 and so on. And so to two significant figures, that is 60 centimeters for the perimeter of, where's it gone? For the perimeter of the semicircle. And that's question 23. Question 24. Write 6.25 times 10 to the minus 4 as an ordinary number. Well, you can work that out on your calculator if you want to. If I put that into my calculator, actually you can't work it out on my calculator because you just get that again. So I'm going to need to do it in the way they intend, by dividing it by 10 4 times once, and now 3 more hops will mean that there are 3 zeros after the point 625. So my answer is 0.000625. Now, part B. Work out that. Give your answer in standard form. Well, on my calculator, I'm going to use the fraction function, and I'm going to enter this sum and press equals and see what happens. So I'm using the fraction button, 2.4 times 10 to the power of 12, and then on the denominator of the fraction, 9.6 times 10 to the power of 4. Press equals, and I get the answer 25 million. 25 with 6 zeros. And I have to give that in standard form, so that's going to be 2.5 times 10 to the power of 7. And that's question 24 done. Question 25. Factorize. Right, now that's a quadratic, so it's going to go into 2 brackets. I'm going to have y and y. Now I see that my 2 numbers multiplied to a negative. So I know immediately it must be a plus and a minus. And now I'm looking for factors of 48 that will end up with minus 2y. So I'm going to have 6 plus 6 and minus 8. 25b. Write down the inequality shown on the number line. Well, it's definitely, if I call it x, it's definitely x is less than 3, but I see that this is coloured in, so it's x is less than or equal to 3. Part C, solve the inequality. Right. Well, I'm going to solve this in much the same way as I'd solve an equation. So the first thing I'm going to do is I'm going to see which side has the fewest w's and float and ping them. So I'm float and ping those 7 w's. So that's going to give me 6. It's greater than, now the 7w becomes minus 7w, 12w minus 7w, 5w plus 14. Now I'm going to float and ping this plus 14. So I'm going to get 6 minus 14, so that's minus 8 is greater than 5w. Now, I'm going to write it the other way around now, but be careful. When you write it the other way around, if it's minus 8 is greater than 5w, it's going to be 5w is less than minus 8. Do you notice how this sign turns around? Now, I can escalate down the 5, which is going to give me w is less than minus 8 over 5. And if you put minus 8 over 5, minus 8 divided by 5 in your calculator, you'll get the answer minus 1.6. So you could write x is less than minus 8.5. You could write x is less than minus 1.6. Or you could write x is less than minus 1 3/5. It wouldn't matter. Either way, you'd get your marks. And that is question 25 complete. Where is it? There it is. Mr. Wright here, and well done for making it through to the end of the paper. In a moment, I'll show you the grade boundaries, and I'll show you how to calculate what grade you would have got had you been sitting this paper or this set of papers. But first, if you found these video walkthroughs useful, please do hit like. It really helps the channel, and it tells me that you have found the film useful, and it's good to have some positive feedback. Of course, if you want to see more of the same, do subscribe to the channel, and then you'll get notifications every time I post something new. So, the grade boundaries. Well, here they are. And what you need to do is to add together your 2 marks on the 2 papers. Of course, both marks out of 100, so that gives you a total out of 200. And then you can use this table to read off what your grade would have been had you sat this set of papers. Leave me a comment, tell me how you've done, and good luck with your exams.